This is the screencast for section 2.4, example 6. We're going to establish upper and lower bounds of a function. Now what's different about upper and lower bounds is that we usually refer to upper as the direction up dealing with the y-axis and lower down on the y-axis. But in this case, an upper bound is a k value that after that k value on the x-axis, the y values will never cross the x-axis or never touch the x-axis. So in other words, y doesn't touch the x-axis to the right of k, means that k is an upper bound. If the y values don't touch the x-axis to the left of k, then k is a lower bound. Now, to determine whether a number is an upper bound or a lower bound, an upper bound occurs when every number in the last line of synthetic division is non-negative, positive or zero. That's an upper bound. A lower bound is when the numbers in the last line of synthetic division are alternately non-negative and non-positive. So never zero, but they alternate between positive and negative. So let's look at an example. Example 6. Prove that all of the real zeros of f of x equals 2x to the fourth minus 7x cubed minus 8x squared plus 14x plus 8 must lie in the interval from -2 to 5. This does not say find the zeros. It says prove that all of the zeros are between -2 and 5. So to me, I have to think, well, what do I have? What rule do I have that can limit our zeros to being between -2 and 5? Well, I have the rules of upper and lower bounds. So the first thing I'm going to do is plug in -2 as my k value. So now I can say that the last line in synthetic division, when k equals -2, alternates between positive and negative, making -2 a lower bound. The last line of synthetic division, when k equals 5, is all filled with positive numbers, therefore 5 is an upper bound of f of x. So since -2 is a lower bound and 5 is an upper bound, by definition, the zeros cannot occur to the left of -2 or to the right of 5, therefore the zeros must occur within the interval -2 to 5. The now try problem is number 37. Use synthetic division to prove that the number k is an upper bound for the real zeros of the function. So for an upper bound, I am looking for all positive numbers in the last line of synthetic division. So I'm going to plug in k as 3 in synthetic division. And I can see that all the last numbers are positive. So since the last line of synthetic division is all positive, k equals 3 is an upper bound of f of x.